So hello, welcome in today's video. Today we are going to solve a question on the system of linear equations. It's a question on Kramer's rule which we'll solve through a determinant, right? You can see this question. It says the system of linear equations, this, and this gives us some solution, right? And the options are: 1 is inconsistent when a equals to 4, 2 has infinitely many solutions for a equals to 4, 3 has a unique solution for mod of a equals to root 3, 4 is inconsistent when mod of a equals to root 3. Now let me tell you one thing. When we look at this question, we see that all we need is the value of a. So we will not make this question very big. What I mean is that we will not find delta x, delta y, delta z, everything. All we will find is only this single delta, and our job is done, because from that we can find a. Now see the coefficient of x in the first equation, 1. Coefficient of y in the first equation, 1. Coefficient of z in the first equation, 1. Now coefficient of x in the second equation, 2. In the third equation, 2. Now such as for y, it's going to be a 3. It's going to be a 3 right here. Yeah. Now we can see for z, 2. And here it is, wait a second, it is a square minus 1. And this is our determinant, right? We can see that this is our determinant, right? Okay. Now what we're going to do is we're going to apply some operations to make this more easy. Now the operation we're going to apply is that column 1 goes to column 1 minus column 2. Now you are going to say that why am I doing this? This 1 minus 1 will become 0, 2 minus 3 will become minus 1, and this 2 minus 3 will also become minus 1. So we will get such a determinant which will be 0, minus 1, and other terms will be as it is, same, right? Now what we're going to do is again apply another row operation, right? We can see that row 2 has minus 1 and row 3 has again minus 1. So what we're going to write is that row 2 goes to row 2 minus of row 3, right? Because when we're going to do that, then the new determinant which is going to come is 0, minus 1, and yes, indeed the other terms will also change, as we got the same here, right? We got the same here. Okay, so now after you apply these row and column operations, after applying these, what you will get is, let me show you. Okay, let me show you what you will get after applying these. Let's go back ahead. You saw the row operations, and after applying these row operations, what you will get is our final determinant is 0, minus 1. Oh, and we got 1 here, another 0, and a 3, and a square minus 1, a 1, and a 3 minus a square. Now as you can see that we got, let's take the different color. As you can see that we got 2 zeros here. Then when solving for the first 2 terms, we can cancel it out, right? Okay, and we're gonna solve. The first term is 0, the second determinant is 0, so we're only gonna solve for the third determinant, which is minus 1. Okay, which is minus 1 into we can see here that we cut this line we cut this line and we write whatever we are left with. So that is 1 and a 0 and a 1 and a 3 minus a square, right? Now when you are going to solve this, you can see that this term is 0. So we cut this. Minus 1 into 3 minus a square, right? Which gives us minus 3 plus a square, right? Now we got, solving this only, we just applied row operations. We got minus 3 plus a square, and obviously the determinant is equal to 0 as we know, and here we get a equals to root 3. Okay, so when we get this, we see that option 2 is cancelled out, option 1 is cancelled out, because they both say, we don't care that in option 1 it's saying inconsistent, infinitely, or anything. It's nonsense, because we see that it says a equals to 4, a equals to 4, which is not possible. Now when we come to question option number 3 and 4, we got to see which one is correct. Now let's go ahead. Okay, so let's go ahead. Okay, so let's first cut this and let's cut this. Now let me tell you one thing. Here you can cut option number 3 also. Now we're gonna say why? Because this inconsistent means no solution. This inconsistent means no solution. Okay, the meaning is no solution. Now let me tell you why can you cut 3. Because when you look at this equation, first equation is x plus y plus z equals 2, 2x plus 3y plus 2z equals 5. Now put the value of root 3 here. Then what you're going to get for the third equation is 2x plus 3y plus root 3 square is 3, and 3 minus 1 is 2, and a is root 3, right? Or as if you can see that mod of a is root 3, then root 3 plus 1. Now you can see that this is 2x plus 3y plus 2z equals to 5, and this is 2x plus 3y plus 2z equals to root 3 plus 1. So this same thing, let me show you, this same thing cannot be equal to this and this. No, because root 3 plus 1 is not equal to 5, right? Even if you're saying that mod a is root 3, okay, I understand you want to take plus minus root 3, maybe, or 3 or whatever. No, but 2x plus 3y plus 2z is equal to 5. That is given in equation number 2. But equation number 3, we don't see that here it is becoming 5. It is becoming some other value, which even if we calculate, it's gonna be a root 3, you know the value of root 3, 1 point whatever. You're not gonna get 5. No, it's gonna come in decimal, 4 point something or 3 point something. But we don't need to look at that. We just have to do this part in my mind, right? First we saw option A cancel, option B cancel, because we got a equals to 4. But now when we see option C and D, we get confused. But no, we got to look at the equation. We're going to see, oh yes, option 3 also cancel out. And after doing so much of this, we finally get option D as our answer. And this is the correct answer, option number 4. And this was a question of JEE Mains Online 2019. This was a JEE Mains 2019 question, which you solved in no time. Now let me tell you one thing. You could have done this whole question in your mind if you did the row and column operation very nicely without a plus minus mistake. I'm serious. But I had to do it right here to show you. So this became something like 0, 0 and sometime here. And then we just cut the two zeros, because the first determinant becomes 0, the second determinant becomes 0. So no value of this first and second determinant. All we have to follow is solve this third determinant. And after solving, we got our answer root 3. but here it's mod A. But even if it's mod A, we see that it does not verify this. So yes, this is our answer. And if you liked it, thanks for watching. Like and subscribe. And solve. And JEE mains questions are not always tough. You just have to know how to solve them. This was a solvable question in your mind, and this could have been done under 30 seconds. If you did the row operation nicely, add column operation, because if a person who was not doing a row or column operation, he would have solved it. Even if I solved directly, this was maybe a 1 minute 30 seconds question, but I did row and column operation, and I saw that we can make zeros, right? You could maybe do another operation like 2 minus 2 0, 3 minus 3 0. That would also make sense. But if you do that, then you're gonna say like 1 0 2. Then what are you going to do? You can't make another 0. Here also you will get stuck in the same way. Oh yes, you made 2 zeros here in this column, so you can solve through the second column, right? Yeah, you can solve through the second column, but that would be a little bit messy. So this would be a better option, as you can see, making this 1 minus 1 0 and solving it. Thanks.